Hello, ladies and gentlemen. My name is Maksim Torba, and the topic of my report is increasing the operation stability of the electron accelerator based on ion-electron emission. Electron accelerators based on ion-electron emission are used not only for research but in industrial field due to such characteristics as simplicity and reliability of the design, moderate requirements for the pumping system, and others. For such accelerators, one of the most important parameters is stability of operation, and methods of its improvement are topical problems in field of acceleration technology. In this work, the criterion of stability is the appearance of cathode spots in the region of auxiliary discharge. Their negative impact on the stability can lead to a local increasing of plasma concentration, increasing the probability of breakdown of the accelerating gap, and reducing the strength of the foil and the probability of its breakage. The aim of this work is to increase the stability of the operation of an electron accelerators based on a non-self-sustaining glow discharge. To reach this goal, I set some tasks. Research the mechanism of increasing the gas pressure during the generation of auxiliary discharge plasma and an electron beam. Research the stability of the operation of electron accelerator in a high-frequency pulse mode on generation auxiliary discharge, and research the effect of the appearance of cathode spots and their influence on the stability of the parameters of the system. The object of research is Y-aperture electron accelerator based on a non-self-sustaining high-voltage glow discharge. The design of the accelerator on figure 1 include two main areas. The area of auxiliary discharge to create the anode plasma, and the area of combustion of the main non-self-sustaining high-voltage glow discharge. The role of auxiliary discharge is performed by self-sustaining glow discharge, in which two tungsten wires as anode and the walls of the chamber as a cathode. Ions are extracted from the boundary of the emission plasma, accelerating in the accelerating gap, and bombard high voltage cathode. Then electrons appear accelerating and in accelerating gap and outputted in atmosphere through a thin metal foil. On this slide you can see a scheme of the experiment. These two electrodes, anode and cathode, the area of plasma generation, auxiliary discharge source, and additional capacitance. This capacitance need to transform several cathode spots to arc. In this slide you can see the auxiliary discharge gas plasma glow with using nitrogen, argon and helium as working gases. All of these gases used in further research. The training effect is one of the most important factors when using accelerators. On this slide you can see the dependence of the number of cathode spots per time on the operating time of the accelerator. If you look at gray graph, you can see that at first 200 seconds the number of cathode spots is large, but then after 400 seconds that number is decreasing to a small increase in about first 600 seconds. Next, the accelerator was turned off, and in 1 hour later, experiment was repeated to find out how much the stability would change in 1 hour. It's a red graph. You can see that 1 hour of accelerator downtime has insignificant effect on the stability of the accelerator. This slide, you can see the traces of cathode spots on the surface of the cathode. The next study was aimed to investigate the influence of system parameters on the appearance of cathode spots. If you look at figure 5 and 6, you can see the dependence of the number of cathode spots on time when changing the pulse frequency and duty factor. If we increase the frequency from 10 to 50 kilohertz, the number of cathode spots is sharply decreased. If we decrease the duty factor from 80 to 30%, the number of cathode spots and their increment per time decrease too. The next study was to investigate the influence on the pulse frequency mode on the stability of the accelerator operation. On figure 7, you can see the dependence of the number of cathode spots on the operation time of the accelerator at continuous and pulse modes, using nitrogen as working gas. If you compare the blue and green graphs, you can see that green graph, which consists to pulse frequency mode, is below, and the number of cathode spots is lower in a pulse periodic mode. On this slide you can see the dependence of the number of cathode spots on the operating time at different pressures when using continuous and pulse periodic modes. If you compare the red and yellow graphs, you can see that if we increase the pressure, the number of cathode spots sharply decreased. The number of cathode spots and their increasing per time. Further, the working gas was changed to argon, to inert gas argon, and you can see the depends on number of cathode spots at continuous and pulse periodic modes. In this mode, the number of cathode spots is fewer than on nitrogen, if we compare it. Experiments were also provided on with helium as working gas, but we can't. It can possible to register the cathode spots on it. There are several reasons for this. First is low sensitivity of cathode spot detector, and second is a high dielectric strength of helium, which means that its concentration is lower than is less than on argon or helium, but the discharge voltage is higher. As a consequence, that leads to greater width of cathode near cathode layer. And the potential stress decreased. In the pulse frequency mode, also during a pulse, the charge of this film is decreased, is neutralized, which reduces the probability of its breakdown. On this slide you can see the diagrams, real oscillograms of the accelerator operation when using pulse periodic mode and working gas helium. An experimental assessment of the probability of the appearance of cathode spots was carried out during the operation of the plasma emitter of the accelerator in both continuous and pulse periodic modes, which showed the advantage of the pulse periodic mode of operation over the continuous one, which consists in reducing the number of cathode spots per unit time. Assessment of the influence of the working pressure on the stability of the system operation showed that it plays a significant role in the appearance of cathode spots on the cathode surface. With an increase in the working gas pressure, the number of cathode spots decreased. Thank you for attention.